Hi everyone, how are you? So in this screencast, we are going to talk about and reviewing for all of you solving quadratic equations by creating a perfect square trinomial, which you know means by completing the square. Okay, before I get to that though, I want to do just this. It occurred to me, I want to do just this. Okay, let's say we were asked to solve an equation like this, and it's quadratic, and it looks like, okay, let's say you're asked to solve for a quadratic equation that looks like this, and I want you to notice that notice there is no x term. Okay, when there's no x term, which means there's no degree one term, you can use what I just call it like the square root method, which is something that you probably knew even before you studied quadratics in detail last year. The square root method means you're going to solve and isolate x squared first. And when you do that, I add 36 divided by 4. That will give me x squared equals to 36 divided by 4, which equals 9. Okay? And then you're going to solve for x by taking the square root of both sides. And when you take the square root of both sides, many people forget x is equal to positive or negative the square root of 9. And in this case, we know the square root of 9, so we will say x is positive or negative 3. Okay? So when you're solving a quadratic equation that doesn't have an x term, if you're allowed to choose whatever method you want to, sometimes the square root method is just the easiest. In fact, I think almost all the time. Just remember that when you are here, when you take the square root, when you get to the place where you are taking the square root, make a note that you don't forget the plus or minus, okay? And yes, this rainbow pen, that was for you, Daniela. All right, so let's talk about solving equations by completing the square. Now, this equation here I'm starting off with, this is what I'm asking you to solve. And maybe you'll notice right away with a quick glance that this is not factorable. I guess I should back up and say I'm checking that this equation has been set equal to 0. It's in standard form, and it is not factorable. And maybe I just don't feel like using the quadratic formula. Well, here's how we're going to complete the square. The first thing I'm going to do is move the constant over to the other side. Oh, I thought I could use it. Oh, I see. Okay. So I have x squared minus 10x. I'm going to leave a space. This equals negative 1. I've moved the constant to the other side. And what's important here is we leave a space because what we're going to do is we're going to add a term to both sides that will create on the left-hand side here a perfect square trinomial. And I think you noticed that in class today we all saw the pattern. And the pattern is taking half of this b term and then squaring it. So half of the negative 10 squared gives you positive 25. Don't forget that when you create the perfect square trinomial on the left-hand side, that you have to balance your equation. So don't forget to add to both sides. Okay? And then what happens is we get x squared minus 10x plus 25 equals 24. This left-hand side now is a perfect square trinomial. Perf square tri. And we can now factor that left-hand side. X minus 5 times x minus 5, right, Tucker? Or x minus 5 quantity squared. This is how Tucker wrote it in class. And now we have we're in a place where we kind of were over here. The whole reason why we complete the square is because we want to create a perfect square trinomial. The reason why we want to create a perfect square trinomial is because we want to be able to just take the square root at some point, okay? And when you are there, we're going to get x minus 5. The square root here undoes this square equals plus or minus the square root of 24, okay? Some of you may remember from Math 2 that we simplify square root of 24 to be plus or minus 2 root 6. If you don't remember it, that's fine. I'll review that, okay, as we move along. So I'm just going to leave it like that number. And then we're going to solve for x. X is going to equal 5 plus or minus square root of 24. So the two solutions here are x plus radical 24 and x minus radical 24. So that is the process of completing the square. I do have one more variation to show you, okay? Notice when you complete the square, you want to make sure you start off in standard form, okay? But you also want to make sure that when you complete the square, you want to be sure that a equals 1, okay? Be sure that a equals 1. Because, for example, you may be asked to solve an equation that looks like this. Okay, let's say we're asked to solve for x here. Notice in this case, a does not equal 1. So what's the first thing you want to do? Well, the first thing you want to do is you want to make a equal to 1. So what you're going to need to do here is you're going to need to divide both sides of the equations by a, which in this case equals 2. And when you do that, what we get is x squared minus 8x plus 1 1/2, or 3/2, equals 0. And now we're going to complete the square like we just did above. I'm going to move the constant over, making sure I leave a space. X squared minus 8x, I'm going to leave a space, equals negative 3/2. I want to now complete the square here. I'm going to add a term that completes the square. That creates a perfect square trinomial on the left-hand side. That's going to be positive 16. Make sure I add to both sides. Now that I've created a perfect square trinomial on the left, I'm going to factor. And when I factor, I get x minus 4 times x minus 4, or x minus 4 quantity squared, equals, oh, don't we love our fractions? 16 is the same thing as 32 over 2. So the right-hand side becomes 29 over 2 after I find a common denominator and I add across. And now I'm going to take the square root of both sides, and when I take the square root, the left-hand side leaves me happily with just x minus 4 equals positive or negative the square root of 29 over 2. And then when I solve for x, I will get x equals 4 plus or minus the square root of 29 all over 2. Okay? So in this screencast, what we've just gotten a little bit of a review and a relearn of is the method of completing the square. And I also started off here with just kind of a reminder that if you have the easiest kind of quadratic equation where x doesn't equal 1, don't forget you have that handy square root method, okay? And then what I'd like you to do after watching this screencast is to now go to your homework. Okay, goodbye.